All right, guys, thanks for logging into Canvas to work on these notes. If you went to the football game, I hope you had fun. I'm recording these notes before I know how we did, so hopefully we are all in good moods. So the last time I saw you on Thursday, we talked about what was happening at these boundaries. We drew those pictures in your notes, and now we're going to get some of that vocabulary a little more clarified because there is a lot of new words. There's things like trench and rift valley and divergent and convergent. There's a lot of new terms. We want to look a little bit closer at what's going on here. So we're doing your seafloor spreading notes. The essential question is what major features form at each type of boundary. And so that's the vocabulary that I'll be really focusing on as we go through these here. So first, a little background information. I showed you that map in class showing that the bottom of the ocean has different mountain ranges like the Mid-Atlantic Ridge and how they're the greatest mountain systems on our planet, really. But prior to the mid-1900s, most scientists thought that the oceans were flat. We just kind of assumed that it was like the bottom of a pond or a lake and everything was pretty smooth and that nothing really changed. Because of the depths of the oceans, we weren't, at that point in time, we weren't able to get to the bottom of the ocean and see what it looked like. Well, something pretty major was happening during the 1940s and 50s, and that was World War II. And so there was a lot of advancements in technology that obviously helped countries in technologies for submarines and win wars, but there were also some technologies that were able to transfer over to the scientific field. And those two technologies are, you'll probably want to jot down, would be sonar. Sonar was used by submarines to find other submarines during World War II, but then science took that sonar and they started aiming them down as this vessel is here, which we'll get to what that vessel is doing. And they were able to calculate the depth of the ocean, is this distance from where the boat is to where the depths of the ocean are. And obviously they were getting different readings and it was increasing and decreasing. The other technology that was invented during World War II that came in handy for science was the magnetometer. That's the device over here on the left. This allows us to see variations in minerals like iron, in terms of where, like what direction they're facing and pointing north or south. And we saw that there was a change in our magnetic field on the ocean floor rocks, and so that was a big deal. And so the invention of sonar and the magnetometer during World War II paid off for oceanographers and topographers and scientists overall, and as far as understanding what's happening at the bottom of the ocean. So thanks to sonar, we looked at this. This is your largest mountain range. I like this map because it makes like the Earth kind of look like a baseball. So there's your Mid-Atlantic Ridge. Here's your Pacific Ridge is broken up into the East Pacific, the Pacific Antarctic, and the Southeast Indian Ridge. So we've named those because there's kind of different things happening in those sections, as you know. It's complicated in the Pacific. In the Atlantic, it's really straightforward. These plates are going that way, and these plates are going this way. In the Pacific, the interactions of plates is not straightforward at all. And so those are those major systems. But all of these areas are areas where a divergent boundary is happening and some sort of new crust is being made. And so these are the places in the world that we get new crust out of, all along those cracks in the crust. Let me double check this. This should be your diagram 1. I got the notes in front of me here. Just got to flip through. Yep, this is something similar to your diagram 1. What you want to notice, maybe, or highlight or circle is the word ridge. When you have ocean floor being separated at a divergent boundary, and it's oceanic crust. Remember, we talked about the different flavors of these boundaries. That is called a ridge. It's the crack in the crust where new ocean floor is being created as the magma comes up and cools. And so I would just want you to circle that word ridge and help you remember that ridges occur at the bottom of the ocean. Here's a more realistic version of it. These things off to the side are basaltic lavas, and they're forming plumes. Kind of pillow lava is what it's called, because as that magma comes up, it is going to cool extremely fast. And so you get these pillow lavas as they're coming out of the crack because of those convection currents in the mantle. It hits the cold ocean water and cools quickly, forming this shape. But this is what your ridge at the bottom of the ocean would actually look like. Now on land, it gets a different name. In class, I mentioned poor Iceland. Poor Iceland. Iceland is literally getting ripped in half. One is on the North American plate and one is on the Eurasian plate, and it's being ripped in half. What forms here is called a rift valley. A rift valley is the name of a divergent boundary that is happening on land. And so you get those low-lying lakes, you get rocks kind of falling off to the side as you pull it apart. There's some earthquake activity, maybe some minor volcanoes. And so one more time, in the ocean, a divergent boundary creates a ridge, and on land, a divergent boundary creates a rift valley. That's a very important difference that you're going to need to know to do well moving forward in this class. Because what we're getting towards is examining, okay, what type of rocks are we going to find here? This all comes down to rock types. I know you're thinking, when do we learn about rocks and minerals? Well, we got to get the general idea of the earth first. The other place this is occurring is the East African Rift Valley. You notice that there's these different sections. It's a complicated ridge system. It's not nearly as cut and dry as Iceland is, but the East African Rift is another area where a divergent boundary is occurring on land. So you're getting that Rift Valley. So obviously, if crust is being created in one region, that should say one region, but the earth isn't getting larger, it must be getting destroyed somewhere else. So all of those places around the earth, all of these places here are creating new crust. If that was just the case, then we would be getting larger, but we're not. So what's happening? At the opposite, we have things called trenches. A trench is a region where this looks like an oceanic continental. So I tend to use letters to represent those. So I would say this is an oceanic continental, or an OC, convergent boundary. We talked about how the oceanic crust is more dense. It's going to get subducted. Friction is going to heat that up, making our magma plumes, or what I call in science, hot pockets, that will rise up through the overlying crust, creating these mountains and volcanoes. In this case, we are looking at the Aleutian Arc. That is Alaska. If you've never noticed that chain of islands coming off the tip of Alaska, we'll have to look at that in class because it's being created by tectonic plates. Here's another deep sea trench that's happening. Notice how it's the Caribbean plate and we've got the North American plate smashing into each other. One is getting subducted, literally creating Puerto Rico. So this is the Puerto Rico Trench. This is where this plate is going down. Here we go. It's going underneath. That friction is rising up, creating Puerto Rico. Puerto Rico exists because of subduction. It's at a trench, and that's the only reason that it even exists. So here's another map. It's kind of redundant, showing some of those ridges, and then also showing some of those trenches. So something to note in your notes, that ridges are what's created at a divergent boundary, and trenches are what is created when crust is being destroyed at a convergent boundary. Make sure you get that in your notes the right way. You can pause it if you need a second. Divergent boundary makes ridges, convergent boundaries make trenches. Fun fact, yay, fun fact time. In case you were curious, the Marianas Trench is the deepest place on the planet. It's also, if you are a Transformers fan, in the second movie, when they put Megatron at the bottom of the ocean, this is where they put him. Obviously, spoiler alert, Megatron doesn't stay down there, but it was a nice try by humans. And so it is more than 11 kilometers deep. Mount Everest, the world's tallest mountain, stands at 9 kilometers above sea level and could fit inside the Marianas Trench with 6 Empire State Buildings stacked on top of it. So here is where the Marianas Trench is. It's on one of those Pacific trenches, very close to Japan, just kind of south of Japan here. There you go. That's where we're at, is the Marianas or Marianas Trench. All right, here's another name you got to know. You only have to know 2 names for this test. Alfred Wegener, who had the idea of continental drift. But then comes Harry Hess. Harry Hess comes in. Here's Harry Hess. So Harry Hess was able to take that technology that formed during World War II, your sonar and your magnetometers, and he came up with what Alfred wished he would have known, which is the theory of seafloor spreading. So Alfred Wegener He had his evidence, his fossils, his climate, geology, and coast and shape of the coastlines, but he couldn't explain how. So everyone thought he was crazy. Harry Hess had the data showing that there are areas of the ocean that have younger crusts and older crusts, and that new crust is being created in one spot and destroyed in another. And he wrapped this all together as the theory of seafloor spreading, which states or explains how new crust is formed at ocean ridges and destroyed at deep sea trenches. So the two names you'll have to know for your test on Tuesday, we'll talk about that at the end here. Alfred Wegener, theory of continental drift. Harry Hess, theory of seafloor spreading. So those are your two main things that you need to be aware of. So when they were using the sonar and the magnetometers, the different scientists involved, the geologists, the topographers, the climatologists, this is the ridge right here. And what they found was that younger rocks were being formed and found close to the ridge, and that older rocks were farther away from the ridge. So obviously it's moving. And then a more obvious observation is that the sediment at the bottom was much thinner close to the ridge, and it was much thicker far away from the ridge. So things like shells, dead ocean creatures, sand, rocks that have moved around and settled. The thickness of sediment gives you a good idea of what is happening above, and there was a lot more of it farther away from the ridge. So that was a piece of evidence they used to support this idea. So the result of seafloor spreading is the new crust is by mid-ocean ridges, and the older crust is closer to the continents. So new crust is by a ridge. That's where the baby crust is sometimes what I call it. And the older crust is further away by the continents, kind of coming up on those trenches where it's going to get destroyed or recycled. So a quick review of these trenches of where this material is being recycled is convergent boundaries. We drew these pictures in class on Thursday. There's the oceanic convergence, where the older, colder, denser plate subducts. There's the oceanic continental convergent, where just the oceanic plate subducts. And then there's the continental convergence. Eventually subduction happens, but I want you to be more focused on the fact that for the most part, mountains are created. The subduction happens a lot lower and a lot slower. And so what we deal with modern day is the formation of these folded mountains, is what you put in your notes, hopefully as an example. This is kind of, what's the phrase, beating a dead horse at this point, ridge and a rift valley. If you're looking at oceanic crust, you are looking at a ridge. Rift valleys only occur on land. Once again, our popular ones are in Iceland, where it literally, the Mid-Atlantic Ridge slices Iceland in half, chow. And you've got it spreading, and there's new land being created in the center there, making a rift valley. And then also in Africa. I feel like this one might be out of order. Yeah. Oh, no. Okay. So lastly, the transform boundary, which we haven't mentioned much because we're going to use extensively when we cover earthquakes, because this is where all of the good earthquakes happen, is at transform boundaries. The San Andreas Fault is a popular example. I gave the example in class that Los Angeles will continue traveling up the coast of North America and cram into Alaska one day in like 250 million years. Something worthy of knowing for the test is that no lithosphere is being created or destroyed at a transform boundary. Nothing's being created or destroyed. It's just sliding. So the stress is going to build up and get released in an earthquake. Here's an old school looking picture showing a farm after an earthquake. The stress built up and then it snapped, and that crust obviously traveled a great distance during this earthquake. So their crops aren't going to be in a row that year. Here's another one. Because California has so many different farms and orchards and vineyards, it's really easy to see how these trees used to be in a line. But because it was built on the San Andreas Fault, there is some shifting going on. So probably every 5 or 10 years, the trees will be in order, and then another 5 or 10 years, the trees will not be in a row. So hopefully that farmer's okay with that. We can skip this part because this was apparently when I taught earthquakes first. So in summary, look how fast we can get through notes when I'm not distracted a lot during class. 14 minutes, nice. Monday, our plan is we're going to do some review activities focusing on those features: rift valleys, trenches, divergent boundaries, and the differences and what's happening, and then real world locations. So we're going to spend a lot of time on Monday just reviewing all these concepts that, frankly, we taught really fast. And then Tuesday, before Thanksgiving break, we're going to have a test on the layers of the earth and plate tectonics. This will be your first big test grade. The only ones we have in there so far is our first quiz on geologic time, our pop quiz on plate maps, and the boundaries, and then this will be our first large test grade, which will be nice to kind of help balance out those other things that they didn't go as well as you had hoped. Thank you so much for taking 15 minutes out of your weekend to get these notes. You will be way more ready on Monday than the people who don't do this. So enjoy your weekend, and I'll see you Monday.